Alright, so we're heading into the last chapter. I hope this is a really easy chapter for you. 7.1 I'm confident it's going to be easy because it's just sketching graphs. And sketching graphs, because my table does my calculator does tables, is going to be very friendly. The title to this section is Graph of an Exponential Functions. And to be an exponential function, it implies the letter is part of the exponent. I'll just write some exponential functions. Each of these would be an example of an exponential function, specifically because on the right-hand side of the equal sign, the x is part of the exponent. For every time I make a graph, I like to make a table, and for exponential functions, the graph that I get is going to be dependent on the exponent, or the table that I get is going to be dependent on the exponent. So for these functions, if the exponent doesn't have a plus or minus sign, just x, I will use this table. For my x column, I'm going to put 0 in the middle, and then I'm going to go smaller and bigger as many points as I need. At first, I'm going to do more than 5 points, but eventually when I get comfortable graphing exponential functions, I'll get down to 5 points. But at first, I'll probably do 7-point tables. Eventually, I'll probably just go between -2 and 2, kind of like we did with parabolas. And then for the next two, if the exponent, so this would be for f of x equals 2 to the x. If the exponent has a plus or minus sign, change, just like we did with parabolas and parentheses, the sign in the exponent and put that number in the middle of my x column. So for the g of x equals 5 to the x plus 4, the number that's going to go in the middle of my x column is -4, because that's the number in the exponent with its sign changed. And then I'm going to get smaller. I can go -5, -6. That's probably where I'll eventually stop. I can do -7, -8, -9. I can do as many points as I want. They're not terribly hard to get if I'm using my calculator to generate the y's. And then I'd get bigger too. So eventually, I'm going to limit my graph to 5 points. Well, I probably should went all the way up to the -6. Sorry about that. Eventually, I'm going to make my graph to 5 points. But at the beginning, I'm going to do 7 points until I think you're more comfortable with what exponential graphs look like. But again, doing 7 points is not such a big deal. And for this function right here, this h of x equals 3 to the x minus 2 plus 1, this plus 1 over here is going to impact the y's. It's not going to impact my table. The table that I'm going to use for this, I'll look to the exponent, take the number in the exponent, change its sign, and then go smaller and bigger. And there's only 5 numbers there. Probably by the time we get to that kind of graph, which is a little more advanced, I'll probably be doing just 5 values in my x column. So if you can get your table set up nicely, you could use your calculator to generate the y's, and then you plot the points and you sketch a graph. It's not going to be hard to do. We will have to identify the domain and the range of the graph. The nice thing about this is the domain for every graph in section 7.1 is going to be negative to positive infinity. So I should probably make that comment. The domain of the graph of every exponential function. I can't think of one that, I better say most every, just in case there's one that I'm not thinking of. Every one that we're going to do, of most every exponential function is negative to positive infinity. And for us, the range, I think of all of our graphs, but I'll say of most of our graphs, will be round parentheses, some number, comma, infinity. I don't think I have anything that doesn't fit that mold, but I wrote these problems a month or so ago, and maybe I snuck in something that I don't remember sneaking in. And more often than not, that number is 0. So for the first graph, I'm going to get my y's by hand and by my calculator. Maybe for the second graph, I'll get the y's by hand and by my calculator. And then eventually, I'm just going to use my calculator to get the y's, because it's just tedious to do it by hand, and it's not particularly hard. So I'm going to plot 5 points, sketch a graph, state the domain and the range, and then I'm going to wind up having fractions or decimals in the y column, and one decimal's got to be enough. And when I was doing parabolas, I was doing 2 decimals, but my graphs are never accurate enough that it even makes sense to show 2 decimals. So I'm going to make my table, do the x column first, get the y's, usually with my calculator, plot the point, sketch a graph, look at the graph and say what my domain and range is. The domain is going to be negative to infinity to positive infinity for every graph, and then the range is going to most often be 0 to infinity, but sometimes it's going to be some other number to infinity. And then I'll be done. So I brought graph paper. You don't need graph paper to do these, but I'll use it just because I think it makes a little bit nicer graph. So for problem 2, my function is f of x equals 2 to the x, and when the exponent doesn't have a plus or minus sign, the number that goes in the middle of the x column is 0, and then you can go smaller and bigger. And for our first graph, I'm going to do 7 points. I can get each of the y's by hand, but I probably would do them on my calculator, and I probably will do them on my calculator. For the first y, I'm going to change the x to -3, and that's going to be 1 over 2 cubed, which is 1/8. And my calculator might give me 0.125 because that's the decimal equivalence of 1/8. I'll write 0.1 for that. So in your y column, 1/8 is completely fine. and 0.1 is maybe what my calculator gives me. In terms of showing up on my graph, I find -3 on the x-axis, and then 1/8 or 0.1 is just above the -3 here. It's going to be just almost on the axis, but it's just microscopically, or it's 1/8 of the way between 0 and 1. It's positive, so it's up. The second point I'll get by plugging in -2 for x. I'll go 2 to the -2 power, and that will give me 1/2 squared, which is a fourth, and a fourth is 0.25. I'm going to write a fourth here. You could write 0.25, or you could round it up to 0.3 because that would be proper to round it up. This might be one of the rare times that I give you 2 decimals, but if you wrote 0.3 because I said to round to 1 decimal, I can hardly take points off. So the next point, I'm going to go find -2 on the x-axis and go up 1/4 of the way between 0 and 1. And that's probably closer to half the way. It's probably a little bit too high. I should have made it a little bit lower, but it is what it is. My graphs don't need to be super, super accurate. They can just be kind of, close. The third point, I'll get 2 to the -1, which is 1/2 to the first, which is 1/2. And for 1/2, I could also write 0.5. And then -1 and 0.5 maybe is about there. You go to -1 and then halfway up. The fourth point, 2 to the 0 power. Anything to the 0 power is 1. So my fourth point is going to be the 0.01. The points will get easier to graph now. The fifth point, 2 to the first power is going to be 2. So now I go to the 0.12. And the sixth point, 2 to the second power is 2 squared, which is 4. So then I plot the 0.24. And then the last point, I put 3 in for x. I get 2 to the third power, which is 8. So 3, 8. It turns out that most exponential functions stay above the x-axis. They don't touch or cross the x-axis. The only way they could touch or cross the x-axis is if after this 2 to the x I had a minus some number. That would make the graph go beneath the x-axis, and I don't have that here. So I'll say again, most of our graphs will get real high on one side and then stay just above the x-axis on the other side. And that's the case here. The right side is a little bit easier to see. If I'm connecting these points, the next point would be 4 and 16 if I plugged in, because 2 to the 4th power is 16. So on this side, my graph's going to get real high real quick. And that's going to be 532, 664, and so forth. But on the left side, my y's are always positive. 1/2 is positive, a 4th is positive, an 1/8 is positive. The next number would be a 16th, then a 32nd, then a 64th. It should happen that your graph it gets closer and closer to the x-axis. We say it asymptotically approaches the x-axis, which means it gets so close to the x-axis that you need a super powerful magnifying glass to see that the graph is slightly above the x-axis. It stays above the x-axis. It doesn't ever cross nor dip below the x-axis. And it's hard for me to draw that, and the further off I go to the right, the closer my graph is going to look to get to the x-axis, and eventually you won't be able to really distinguish my graph and the x-axis going off to the left because of the thickness of my pen. So I stopped where you can still see that gap, because there always is a microscopic gap. So I'm done with a graph. I put little arrows at the edges to signify the graph keeps going on. Eventually the graph would go all the way to the left of the x-axis and all the way to the right of the x-axis On the left edge, you'll see the graph the whole time because it just hugs the x-axis. Off to the right, you'd have to get super high to see the top of the graph. But for this problem and for every graph we're going to do today, the domain is going to be negative to positive infinity. There isn't any number I can't put in for x. And then the range, the top of the graph is easy to see. The graph eventually works its way to the top of the y-axis. That's why the end of the range is going to be positive infinity. And then the graph never gets, actually never even touches the x-axis. It's always slightly above the x-axis. And the y-coordinate of the x-axis is 0. So the graph never actually gets below and never even actually gets to y equal to 0. So the range, the graph kind of, it always exists above the x-axis. The y-coordinate of the x-axis is 0. And it goes up to the top of the y-axis, which is infinity. Should have got the table on my calculator. To get the table on my calculator, I would have just done this. I would have turned my calculator on and did mode 7 for table. F of x is 2 alpha x, delete 2 exponent alpha x. And then start at negative 3. End at positive 3, step 1. And my calculator gives me the decimal versions. It gives me the point negative 3, and instead of 1/8, it writes the decimal equivalent, which is 0.125. And I'll write 0.1 there. And then for 1/4, I just have the urge to write 0.25, so I'll write 0.25. And then for -1, I see the 0.5. And then for 0, I see 1. For 1, I see 2. So I can see all the points that I got. Not that you can see them when I move the calculator over here, but it just fights me. And so all the points that I have can be, at least the decimal version of the points can be gotten from my calculator. And then you can plot them. And I'm completely content with decimal wise. As long as you know how to plot the decimals, I'm totally happy with that. 4 wants me to graph 5 to the x, so I'll do that. So 4 is f of x equals 5 to the x. I'm going to use the same starting table because it has the same exponent. Only when the exponent has a plus a number or a minus a number do I vary up my x column of my table. This is less interesting to do by hand, so I'm going to do this one all on my calculator for the table. So I'm going to go mode 7 for table, and then 5 exponent alpha x. Start my table at -3, end my table at +3. Step 1. First point is, can't even read that, huh? So look what it's saying. When I scroll to that, it says 8 times 10 to the -3. That's scientific notation. The first point, 8 times 10 to the -3, the first y, says to take the decimal that we don't write that's after the 8 and drag it 3 places to the left. 8 times 10 to the -3 is 0.008. That's a positive number, but it's 8 1/1000ths above the x-axis. So if I round it to 1 decimal, I put 0. How about I write 0.01 and round to 2 decimals so I don't show a 0. And that point is so close to the x-axis above the -3 that you probably couldn't draw it close enough without having a huge grid to fit it on. The next point is -2.04. Again, if I rounded that to 1 decimal like my instructions ask, you'd write 0. But it's slightly more than 0. It's just microscopically higher than the last point. But it probably should be closer to the axis than I actually drew it. But I just wanted to emphasize it's a little bit higher than the first point. The third point, -1 and 0.2. 0.2 is, again, it's less than a quarter of the way up, but it's still up. 0.2. 0.2. Then I get the nice points, 0 and 1, which is there. 1 and 5, which is there. And 2 and 25, that's already off my screen. And the 3 and 125 is way off my screen. I'll kind of estimate where 2 and 25 is. I'll say 2 and 25 is, it's actually above the top of my graph. My graph only goes up to 19, but I'll say that's 2 and 25 even. It really should be a little bit higher. And so the graph, it's even steeper than the 2 to the x. It's not the best rendition of the graph, but it's good enough. And then on this left side, just like the last graph, it should stay microscopically above the x-axis. It gets super, super close to the x-axis because those points are, 1/1000th and or 1/100th and 4/100ths of a unit above the x-axis, but still above the x-axis. So this is not a stellar graph, but it's good enough. I brought graph paper, and that's about the best I could do. The domain of every exponential function is -infinity to +infinity. The graph would extend all the way to the left, and you could see it the whole way out. And the graph would extend all the way to the right of the x-axis, but it would get super high super quick, where you might not see it, but it definitely exists. No matter how far right I go, I can go up and find part of the graph if I go up high enough. And this is another one that has the same range. If my graph is just settling right above the x-axis, the range goes from 0 to the top of the graph, which is the top of the y-axis, which is infinity. And for these graphs, you get all round brackets because the graph actually never touches 0 on the y equal to 0, which is the x-axis. Six is still not that interesting in terms of a table, so I'll do this all on my calculator. Once I get to a problem that has like a fraction where the table is a little more complicated by hand, I'll do the table by hand. So for 6, I'm asked to graph f of x equals 4 to the x minus 2, and we're going to treat the minus in an exponent just like a minus inside a parentheses for the parabolas. And in the middle of my x column, I'm going to put the number 2, and then I'm going to go backwards. And for now, I'm still doing 7 points until I get comfortable with how the graphs look. So I changed the sign of the number in the exponent, put it in the middle of my x column, then I went smaller and bigger a few. Now I'm going to get the y's. So mode 7, f of x equals 4 exponent alpha x minus 2. Start at -1, end at 5, step 1. First point is 0.02 with -1, so it's 2/100ths. It's just barely above the x-axis. The next point, 0.06, I can round to 0.1 if I want to, because my instructions say to round to 1 decimal. And then 0.25, I could round to 0.3, or I could leave it 0.25 without I even have a sense of how to graph that better than I do 0.3. And then 2, 1, 3, 4, 4, 16, which would be the last point I'll be able to get on here, and 5, 64. I won't be able to graph that because it's kind of off my grid. So first point, -1.02. 0.02 again, it's above the x-axis because it's positive, but it's even closer to the x-axis than I actually drew. And then 0.1, 0.1 is 1/10, which is 10/100ths, is bigger than 2/100, so it's higher than my last point, but still not that high. And then 1 and then 1/4. I almost made that, it's a little bit under 1/2, but I made it closer to 1/2. It's good enough though. And then 2 and 1, 3 and 4, 4 and 16. I can't do the 5 and 64 because 64 is way too high for my... Gosh, can't even draw a nice long graph. Sorry about that. And then again, just like the last two problems, the graph, it probably should be closer to the x-axis than I have it drawn, but I just want to emphasize that there's a gap between the graph and the x-axis. I don't want to make it look like the graph is on the x-axis, but in reality, it's so close to the x-axis that if I drew it properly, you wouldn't even see the x-axis anymore. But there is a slight gap. And then this, you know, I should have, God, I still can't do that, but still not that good. It's never going to be that good, so I should have lived with what I had. And then again, the domain for all exponential functions that we do are negative to positive infinity. They exist all the way to the left. That part's generally easy to see. They exist all the way to the right, but they get so high that you can't see that they exist, but they do. And just like the first two problems, this graph stays above the x-axis, which has the equation y equal to 0. The graph never touches the y equals 0, but it stays above the y equal to 0, and it goes all the way up to the top of the y-axis. Eight's not going to be much different. To do 3 to the x minus 1, not upside down. I'm only going to do 5 points this time, because we've done 3 graphs already. And they all kind of start to feel the same. Once the graph starts to do something different, I'll go back to more points. So for my table, I'll take the number inside the exponent, change its sign, -1 goes to +1, then I'll go smaller, 0, -1, bigger, 2 and 3. 5 points is kind of the minimum of what I do for an exponential function. If you want to do 7 points or 9 points or 11 points, it's fine. Your calculator will give them to you so quickly anyways. It doesn't really take much more work. But most of these graphs look the same. So once you've graphed a few, you probably don't need as many points. So now mode 7 and then 3 exponent alpha x minus 1, start at -1, end at 3, step 1. And again, I look to the exponent. If it has a plus or minus sign, I take that number, change its sign, and throw it in the middle of my x column. So my first point's the -1, and then I'm going to write 0.1. The second point is 0, I'm going to write 0.3. Third point is 1 and 1. Fourth point is 2 and 3. Third point is 3 and 9. You're welcome to do more points if you want. But this graph is going to look a lot like the last 3. And 5 points is probably enough for me. So -1 and 0.1, that point's just above the x-axis at -1. 0 and 0.3, that's up a little more than a quarter of the way. It looks like I made it more like half. 1 and 1, 2 and 3, 3 and 9. I don't own graph paper. I just did like a Google search and found some graph paper and printed it out rather than buying the graph paper because I can print for free on campus. You don't need graph paper to do these graphs, but if you feel the urge, you don't have to buy graph paper. But if your ink costs more than the what you could buy graph paper for, then you can buy some. But I don't require it. It's absolutely not necessary. So to finish up this graph, right side generally goes high. Left side generally stays just above the x-axis. This can flip sometimes. If this number, the base here, is a fraction, it's going to flip the graph over, make the left side go high and the right side get flattened. But we'll get to that pretty soon, I imagine. So I've done my table of values. I'd sketched a graph for every exponential function that we graph, and everyone I can think of, I can't think of an exception, the domain is negative to positive infinity. And just like the last 3 problems, the graph stays slightly above the y-axis, the y-coordinate of the x-axis. The y-coordinate of the x-axis is 0, and it goes to the top of the y-axis, which is infinity. Most of our graphs will have a range of 0 to infinity. All of our graphs will have a domain of negative to positive infinity. For 10, f of x equals 3 to the x plus 2. In the middle of my x column, I'm going to put the number negative 2, because when there's an addition or subtraction inside the exponent, I change the sign of the exponent and throw that in the middle of my x column, and then I go smaller a couple, bigger a couple. Use my calculator again. So mode 7, f of x equals 3 exponent alpha x plus 2, start at negative 4, end at 0, step 1. So I get 0.1, 0.3, 1, 3, and 9. The way I construct my tables, if the bases are the same, you start to see similarities in the y's. That's not a coincidence. That's, you know, kind of my goal, is to get that uniformity in my tables. I could have done all of these by hand. I'll just show you what I would have done to get the y's by hand. For the first one, I would have went 3 to the negative 4 plus 2, which is going to be 3 to the negative 2, which is 1 over 3 squared, which is 1/9, and the decimal for 1/9 is 0.11. The second one, I'd go 3 to the negative 3 plus 2, which is 3 to the negative 1, which is 1/3, or 1 over 3 to the 1, and the decimal for 1/3 is 0.3 repeating. That's 0.1 repeating for the first one. The third point, I'd go 3 to the negative 2 plus 2, which is 3 to the 0, and anything to the 0 is 1. The fourth point, I would have went 3 to the negative 1 plus 2, which would give me 3 to the first power, and 3 to the first power is 3. And then the last one, 3 to the 0 plus 2 is 3 squared, which is 9. So my calculator is just saving me the tediousness of finding the y's. And for me, it's probably just as easy to plot the decimals as it is to plot the fractions, and I don't have any strong feelings that you need to see fractions in the y column. Just want a reasonable graph, and my graphs aren't super accurate whether I'm putting fractions or decimals here. So negative 4 and 0.1 again is just above the x-axis. Negative 3 and 0.3, it's a little bit higher, then they're easy. Negative 2 and 1, negative 1 and 3, 0 and 9. Again, the graph should stay slightly above the x-axis and should get real high on the right side. The domain of every exponential function that we're going to graph is negative to positive infinity. And for most of our exponential functions, the range is going to be 0 to infinity. That's the case when they just stay microscopically above the x-axis. Sometimes the graphs are going to vary from this, and that's going to be, and you'll see little extras. You'd have to be something like 5 to the x minus 1 plus 4. You'd have to have this little extra, a number added or subtracted after the exponential function to make the range not be 0 to infinity. And we'll get to those eventually. 12, 4 to the x plus 2. So in the middle of my x column, I should plug the number negative 2. And then I'm going to go negative 3, negative 4, negative 1, 0. Mode 7 for table, 4 exponent alpha x plus 2. Start at negative 4, end at 0, step 1. The 1's already there. I could just hit equals without typing the 1. I do that sometimes. The first point gives me 0.06 for the y. I'm going to type 0.1 or write 0.1, but I could write 0.06. Or you could round, like I said, to 1 decimal. And then for 0.25, you could write 0.3 because I say it around to 1 decimal. But for whatever reason, I like writing 0.25. It's something I'm more familiar with. And then I just took the rest of the y's from my calculator. And just plot the points. My first point is 0 and 16. My bottom point was 0 and 16. I don't know why I decided to go backwards. -1 and 4. -2 and 1. -3 and a quarter. -4 and 0.06 or 0.1. That's as good as I get. So, made a table of values, sketched a graph. The graph will eventually go to the far left edge of the x-axis. You'll see it the whole way. Eventually it'll go to the far right of the x-axis. You have to go super high to see that. My domain of most, if not all, exponential function is negative to positive infinity. And when the graph just hugs the x-axis, the range is 0 to infinity. I did a lot of these. 3 to the x plus 1. So, hardly that hard. 14. F of x equals 3 to the x plus 1. Middle of my x column, I'm going to put the number -1, change the sign of that, and then I'm going to go -2, -3, 0, and 1. Get my y's. Mode 7 for table. 3 exponent alpha x plus 1. Start at -3. End at 1. Step 1. First point, I'm going to write 0.1 next to it. Second point, I'm going to write 0.3. This is really 1/9 and 1/3. Third point, I get a 1. Fourth point, I get a 3. Last point, I get a 9. Again, I just copied from my calculator. Could have gotten fractions if I wanted to do it by hand. We just don't really have the desire to do that. So, -3 and 0.1 against just above the x-axis. -2 and 0.3 is a little bit higher. -1 and 1. 0 and 3. 1 and 9. Keep my graphs noticeably above the x-axis just because it should be, just to emphasize that it stays above the x-axis. My domain, still negative to positive infinity. The graph stays slightly above the y-axis, so the range is 0 to infinity. First one that we have a lovely fraction. The fraction makes the graph go backwards. Usually our graphs go up on the left and down on the, up on the right, down on the left. Fraction graphs look like this. I'll say they are backwards. And you don't need to know that. If you just do a table and plot the points, you'll see that happen. But when the base is a fraction between 0 and 1, then the graph's going to go backwards. So for 16, I'll do the table by hand and on my calculator, just so you can see how you'd attack a fraction base. The exponent is just x, so the table I would use would have 0 in the middle. And let me do I'll just do -1, -2, 1, and 2. I think 5 points is going to be enough. This would be really tedious to do by hand, and I'm going to do it by hand, but you should probably do it on your calculator. The first point, I'd go 1/2 to the -2 power, and then I have to remember, if you have a fraction that has a negative exponent, by hand, you could make the exponent positive by taking the reciprocal of the fraction. So 1/2 to the negative 2 is 2 over 1 squared, and that's the same as 2 squared, and 2 squared is 4. The next one, 1/2 to the negative 1 power, is the same as 2 over 1 to the first power, which is the same as 2 to the first power, which is 2. The third point, 1/2 to the 0 power, anything to the 0 power is 1. The fourth one, 1/2 to the 1 power, anything to the first power is itself. So I can get 1/2. My calculator is going to give me 0.5. And then the last one I'm doing, 1/2 squared, is you square the 1 and you square the 2. Squaring 1 you get 1, squaring 2 you get 4. That's 1/4, and the decimal for 1/4 is 0.25. Let me, before I plot them, get all the values on my calculator just so you can do that, and I'm completely content with you doing that. So mode, table, parentheses, fraction, 1 over 2, parentheses, exponent, alpha x, good enough for the function. Start at negative 2, end at 2, step 1. You'll see the first point has a 4, the second point has a 2 for the y, the third point a 1, the fourth point a 1. Look at how over here it writes 1/2 kind of in a funky way, but that's 1/2. And the third point, it writes 1/4 when I scroll to it in a kind of a strange way so it fits on the screen. So I can plot all of these points as decimals, or I can get them as fractions, doesn't matter. So first point, negative 2 comma 4 is up there, and then negative 1 comma 2, 0 comma 1, 1 comma 1/2, 2 comma a quarter, and the point that I wouldn't have graphed, negative 3 would be at 8, and 3 would be at an 1/8 if I wanted to get more points, but I sold you short on my points. So, messed up that I made my graph touch the x-axis. The graph should still be slightly above the x-axis. My graphs will never touch the x-axis. They're always microscopically above the x-axis. So what the fraction did is what I said it was going to do. The fraction makes the graphs go backwards, meaning it gets high to the left of the right axis and gets low to the right of the y-axis, high to the left of the y-axis, low to the right of the y-axis. It doesn't change the domain and range though, because the graph still goes, you can see it everywhere if you get high enough to the left of the x-axis, or left of the negative x's, and you can see it everywhere if you go to the positive axis. The domain of every exponential function that we're going to graph is that. And whether the graph is backwards or not, the graph kind of stays above the y-axis, the x-axis, which has a y equal to 0, and goes up to the top of the y-axis, which is at infinity. The only time I'm going to vary, it's going to be a variation of the range, would be if there was a number added or subtracted after here. If there was a number added or subtracted, that's going to impact the beginning of the range. And eventually we'll get to that. 18 is another fraction graph, so it's going to be backwards again. So for 18, f of x equals 1/4 to the x. Whoa. I'm going to use the table that has 0 in the middle, and then if you need more than 5 points, you can go up to the 3's if you want to, but you don't have to. Apparently, if you want fractions, you can just scroll to the y and see the fraction. So let me mode 7 for table, parentheses fraction, 1/4, parentheses exponent, alpha x, start at negative 2, end at positive 2, step 1. So the first point is the point negative 216. The second point is the point negative 1,4, and then 0, 1, and then 0.25 for 1, or you can see over there it's a quarter. I'm going to write 0.25, but you can write a quarter and it actually gives you that. and then the next point is 1/16, which is 0.06. I'm going to write 0.1. Again, for these, I could have written a quarter next to the 1 and a 16th next to the 2, and I could have actually seen the 16th and the quarter. So first point, -2, +16, easy enough. -1, +4, 0, 1, 1 1/4, 2 and 0.1 are a 16th. Oh, apparently I got this from mathaids.com. I really think I just did a Google search and found it on under images, but if you want this exact graph paper, I imagine it's got to be free there. So I'm going to plot the points, make a backwards graph, because when the base is a fraction, then the graphs go backwards. But they still stay above the x-axis. The domain of every exponential function that we're going to graph is negative to positive infinity. And when the graph, whether it's backwards or forwards, kind of hovers above the x-axis, the range is 0 to infinity. Another fraction. ½ to the x minus 1. Still going to be backwards because of the fraction. In the middle of my x column, I'm going to put the number 1 because I'm going to change that sign, and then I'm going to go 0, -1, 2, 3, mode 7, parentheses, fraction 1/2, parentheses, exponent, x minus 1, start at -1, end at 3, step 1. First point is the point -1, 4. Second point 0, 2. Third point 1, 1. Fourth point I can write 1.5, or I can write 1 1/2. So if you get a teacher that needs to see the fractions, this calculator will give you the fractions. And then 3 1/4, I can write 0.3 because I said to round to one decimal. I could write a quarter if I want a fraction, or I can write 0.25 because for whatever reason I feel the urge to write that instead of rounding to one decimal. So -1, 4, 0, 2, 1, 1, 2, 1/2, 3, 1/4. I get a backwards graph. The more points I draw, kind of the better my graph is, but just, again, I'm not worried about it being stellar. Yeah, if you have a fraction as the base, it's a backwards graph. If the graph hovers above the x-axis, it's usually 0 to infinity for the range of an exponential function. So far, our domain and range has been very consistent on the 10 problems that we've done. Eventually, it's going to change. Not the domain, but the range. So it's kind of overkill on problems. 22 wants me to graph f of x equals 1/3 to the x minus 1. Put a 1 in the middle of my x column, then do 0, -1, 2, 3. I think I could do the points in my head, but that would be stupid, I guess, because how long does it really take on my calculator? Oh. 1. So the first point has a 9, the second point has a 3, then a 1, and then 0.33 or 1/3, and then 0.1 repeating or 1/9. I'm just going to plot those points. So -1, 9, 0, 3, 1, 1, 2 and 0.3, 1 and 0.1, 3 and 0.1. So if you fast forwarded to where the graphs get different, I'll tell you where that is in a second. It could be the next problem for all I know. probably would be a good use of your time. If you feel good about the basic graphs, you'll be fine. Oh, 20. So 24, you could probably skip. 26, you could probably skip. 28 is where you might want to start watching again, because this plus 3 changes the range. You might be able to do that without me and find the range. The only thing that's going to be different, well, there might be a lot of things different, but the range is going to get changed on 28. Real quickly, I'll do 24 and 26 just because I want to do every even problem. And they're so fast at this point. Once you get good at these. In 26, the number I'm going to put in the middle of my x column is -3 because I'm changing the sign of that +3. And then I'll go -4, -5, -2, -1. I think my table is going to be 4, 2, 1, 0.5, 0.25. Well, make sure of that. Mode 7, parentheses, fraction, 1/2, parentheses, exponent, x plus 3, start at -5, end at -1, step 1, and 4 for the -5, -4, 2, -3, 1, 1.5, which I could write 1/2 if I need to, -2.25, which I could write 0.3 if I rounded, or I could write 1/4 if I wanted to. So -5, 4, -4, 2, -3, 1, -2.25, -1 1/4. Again, for all our exponential functions, every graph in this section, our domain is going to be negative to positive infinity. And as long as the graph is just hovering above the y-axis, the range is going to be 0 to infinity. And this was problem 24. '26. I'll just do it so you can see it. I think I wrote it down right. So my middle of my x column is going to be -5. Then I'll go -6, -7, -4, -3. I think the y's are going to be 9, 3, 1, 0.3 repeating or 1/3, and 0.1 repeating or 1/9. I'll make sure that's the case. So I'm going to go mode 7 f of x, because I can't have a, well, I could have a g of x, but it would mess me up. Start at -7, end at -3, step 1, first point -7, 9, second point -6, 3, third point -5, 1, fourth point -4.3 or 1/3, fifth point, -3 or 1/9, -3.1 or -3 1/9. Plot the points now. First point's -7, +9, and then -6, +3, -5, +1, -4.3, -3.1. And the graph again should say just above the x-axis. The domain of all our exponential functions are negative to positive infinity. The range of our exponential functions that hover above the x-axis are 0 to infinity. For the next group of problems, the number that's added or subtracted is going to impact the beginning of the range. This number will, with the sign that it has, I'm not going to change the sign, be the first number in my range. So that 3 is not part of the exponent. It's going to impact the graph. For this one, when I do my graph, for every exponential function that we do, the domain is negative to positive infinity. And when there isn't a number added or subtracted after the exponential part of it, the range is 0 to infinity. Here, the range is going to be 3 to infinity. If that was a -3, the range would be -3 to infinity. And it'll come up on the graph. The graph is going to just hover above 3 on the through the y. So let me do this. So f of x equals 2 to the x plus 3. And just to really kind of focus on this 3, I'm going to make a dashed line, kind of like an x-axis through the 3 because of this plus 3. The exponent is just x, and that's the -2, -1, 0, 1, 2. The plus 3 has nothing to do with the initial table. Only the exponent drives the table. And there isn't a sign in the exponent, so I put 0 in the middle and then get smaller and bigger a couple. What the 3 does is it really impacts the y's. So now to do this, mode 7 to exponent alpha x, get out of the exponent, and then do plus 3. Start at -2, end at +2, step 1. First point is 3.25, which is 3 1/4. It's easy enough for me to graph 3.25. I could round that to 3.3 if I want. Second point, -1 and 3.5. Third point, 0 and 4. Fourth point, 1 and 5. Last point, 2 and 7. So -2 and 3.25. 3.25 is just going to be above that dashed line that I drew. -1 and 3.5 is a little bit higher than that. 0 and 4. 1 and 5. And 2, and I'm supposed to write 7, but apparently can't copy. So you can kind of see what I was hinting at, that the points now don't hover above the x-axis, they hover above the horizontal line through 3 on the y-axis, and the graph, we say it gets shifted up 3 units. If you take Math 151, you'll do a lot of these, call them phase shifts. So that would be a reasonable graph. The domain for every exponential function that we're going to graph is negative to positive infinity, and the range, because this plus 3, the graph gets bumped up plus 3, all the y's get added, 3 gets added to all the y's, and it changes the 0 to a 3. For 30, the domain, when I eventually do it, for every graph we're doing today, the domain is negative to positive infinity. What's going to happen with the range is it's going to go from -2 to infinity. If a number's added or subtracted, not in an exponent, it doesn't affect the table, it affects the range. So when I do 30, 4 to the x minus 2, better give myself some room low here. So 30 f of x equals 4 to the x minus 2. What's going to happen is that minus 2 is going to kind of be what the graph is attracted to. So for these problems, I make a little dashed line wherever the number is after the exponential function. The last one I did it at plus 3 through the y-axis. Now I'm doing it at -2. For my table, because the exponent is only x, I get the 0 in the middle and the -2, -1, 0, 1, 2 table. And now mode 7 for exponent alpha x, get out of the exponent and then put a -2. If you put the -2 in the exponent, you'd get a graph like the beginning graphs that touches the x-axis. Start at -2, end at +2, step 1, The first one I get negative 1.9. The second one I get negative 1.75, which I can write negative 1.8 if I care to. Third one I get negative 1. Fourth one I get positive 2. Last one I get positive 14. So first point, negative 2 and negative 1.9 is just above that dashed line that I drew. And then negative 1, negative 1.75, it's close to that dashed line, but it's a little further away. And then 0, negative 1, 1, 2, and 2, 14. And the graph should stay just above this dashed line. For us, the domain of every graph that we do in this exponential graphing section is negative to positive infinity. And the range, when you have that plus or minus, the beginning of the range gets shifted down. So it's negative 2 to infinity. 32, the table is going to be not the standard table, and the range isn't going to be my standard range. Again, for this problem, all our graphs have a domain of negative to positive infinity, and this plus 1 is going to pop up in the range. My range is going to be from 1 to infinity. It doesn't matter how complicated the exponent is in terms of the domain or the range. It's this number there, and it only impacts the range. So when I do 32, f of x equals 2 to the x plus 2 plus 1, I'm going to draw a dashed line through positive 1 on the y-axis because of that plus 1. My table is going to have a negative 2 in the middle because of the plus 2 in my exponent. So I'm going to go negative 2, negative 3, negative 4, negative 1, 0. I could get all of these y's by hand, and it's not ridiculously hard. It's just I don't care to do it. It's not really an algebra problem. It's more of a 082 skill, really. Orders of operations, and we can skip on that because this is more advanced than that. So it looks enough like the function. Enter it, start at negative 4, end at 0, step 1. First point, the y is 1.25 next to the negative 4, and then negative 3, and then positive 1.5, negative 2 and 2, negative 1 and 3, 0, and looks like 5. So negative 4 and 1 1/4 is a little bit above that line. And then negative 3, 1 1/2, again, it's right above that line a little bit. Negative 2 and 2, negative 1 and 3, 0 and 5. Good enough graph. For all our graphs, the domain is negative to positive infinity, and when there's a number after the exponential function, that's going to be the beginning of our range. For 34, that's going to impact the range. The range is going to go from negative 2 to infinity, and I'm going to draw a dashed line through negative 2 on the y-axis. So 34, f of x equals to 5 to the x minus 3 minus 2. The minus 2 part gives me this dashed line through minus 2 on the y-axis, and then the minus 3 in the exponent makes me put 3 in the middle of the x column for my table. And I'll do 1, 2, 3, 4, 5. Enter this function. Mode 7 for table, 5, exponent alpha x minus 3, get out of the exponent, minus 2, start at 1, end at 5, step 1. First one is negative 1.96, I can't round it to -2, otherwise it's going to be on the dotted line. I don't want it to be there. So I'm going to give that 2 decimals. And then 2, -1.8, 3, -1, 4, 3, 5, and 23. So I'll plot those points the best I can. The first point, 1 and -1.96, is just microscopically above that dashed line that I drew. 2 and -1.8 is a little bit higher, but still pretty darn close to that line. And then the rest are easy. 3 and -1, 4 and 3, 5 and 23 I'm going to estimate to be up here somewheres. My graph doesn't go up to 23, but I could live with that. Good enough graph. The domain is negative to positive infinity. The range is -2 to infinity. (36). Hopefully you can predict what the range is going to be because of that -4. So for 36, f of x equals 6 to the x plus 3 minus 4. My table is going to have a -3 in the middle because of the plus 3. Then I'm going to go -4, -5, -2, -1. I'm going to find -4 on the y-axis and draw my dashed vertical line. Now I'm going to make my table. Mode 7, 6, exponent alpha x plus 3. Get out of the exponent, tag the -4 on there. Start at -5, end at -1. Step 1, first point I get -3.97. If I round it to -4, I'd have to plot on that dashed line, and I don't want to. Second point, -3.8 for the -4. Third point for the -3, I get -3. For the -2, I get 2, and for the -1, I get 32. Whoa, no chance of plotting that. So I'm only going to plot 4 points, and I'm going to make my graph real steep. So -5, -3.97 is just above that dashed line that I drew. -4, -3.8 is again just barely above that dashed line that I drew. And then -3, -3, easy enough. -2, +2, easy enough. -132 is way off, way off my paper. The domain for all our graphs is negative to positive infinity. The range starts at where the graph hovers above. In this case, it hovers above -4 and goes up to infinity. Last problem. F of x equals 3 to the x minus 2 plus 4. So I'm going to draw my line through 4 on the y-axis. And my table is going to have 2 in the middle. And then I go up and down. Mode table 3 exponent alpha x minus 2 plus 4. Start at 0, end at 4. Step 1. I get 4.1, and then 4.3, and then 5, and then 7, and then 13. So 0 and 4.1 is just above my dashed line. 1 and 4.3 is a little bit more above the dashed line. My graphs aren't stellarly perfect, but they're close enough. 2 and 5. 3 and 7, and then 4 and 13. Should not touch that line. I should be above that line. My domain for every graph in this section was negative to positive infinity. And my range is going to start at this dashed line with a round parentheses and go up to infinity. So hopefully that was a kind of a friendly section. It's calculator heavy, just plotting points, the domain and range. Hopefully by the time we got through the section you feel good about it. If you're having calculator issues, or if you want to learn how to do all the tables by hand, I certainly can show you. Stop in and I'll give you a by hand lecture, and you can rock these by hand. They're not that hard, just a little bit tedious to do by hand.